So we were at the projectile motion. We will continue that. You can see this diagram. Before we have discussed this, this is a projectile motion example, right? This is a ball. When we throw this ball, it is making an angle right here. It makes an angle here. This is the y direction, this is x. If we talk about the y direction, if we take as a initial velocity, that is Vy is equals to the V sine theta. We have also discussed in the trigonometry in the mathematics. Now here if we talk about this x, so we can write Vx is equals to the V cos theta. We have discussed this in vector chapter also. This will be the simple V, right? And this is a Maclaurin angle. This we have discussed about in the resolution of the vector, when we resolve these both vector in the Vy component and Vx component. So this will be the, if we talk about y, it will be the Vy, and in x if we talk about, it will be the Vx, right? So the Vx will be same everywhere. This will be the Vy here, and we discussed that Vy will be 0 at the highest point, and here Vx is equals to the cos theta. This Vx cos theta will be the, Vx is equals to the V cos theta. This will be the same, this will be the constant everywhere. Vx velocity will be the constant everywhere, so that's why acceleration is 0 here, because this is constant everywhere. But the Vy, we talk about Vy, this is variable, this is not constant, and the highest point, this is the 0. So Vx, and here Vy, and here Vx, here it's g gravity, and here Vx, and here Vy. So this we have discussed before, right? And here if we talk about, here Vx is equals to the V cos theta, and Vy is equals to the V sine theta. Here and here, this Vy will be the same here and here, but not here when it's moving upward and coming downward, and here it will be the 0. So this we have discussed before. If we talk about here, like Vx is equals to the V cos theta, right? So it is constant everywhere, it is constant, and Vy is equals to the V sine theta. It is variable, which means it vary everywhere, but at highest point, it is equals to the 0. So that before we have discussed. But if we talk about in 2 dimensions, motion in 2 dimension, so we have resolved this in the 2 direction, that's the x direction, and in the y direction, right? We have resolved this in x direction and y direction. We have discussed that the Vx is equals to the V cos theta, and acceleration of x component is 0 in the x direction, and here Vy is equals to the V sine theta, and here acceleration of y component is the minus d. We have discussed before. But if we talk about more in the general analysis of the Vx and Vy direction, here we will discuss about the general analysis of projectile motion, We will break into 2 components, that's the x direction first, and in the y direction. Now here we will derive some formulas. Suppose that distance, what distance it cover in the x direction, what distance cover in the y direction. What we have talked about the initial velocity, right? What will be the final velocity in the x direction, what will be the final velocity in the y direction. So we will discuss it here. So here we will discuss. So as we know, initial velocity was the Vx is equals to the Vx is equals to the V cos theta, right? This is the initial. And here acceleration was the 0, ax was 0. But if we talk about the final here, so in final we take initial as the vx and we take final as the ux. This is the initial, and this is a u will represent as the final. In y component we will also do the same as a vy and uy, right? Here if we talk about the final, so as we know that final velocity if we talk about the motion, the equation of motion, that vf is equal to the vi plus at, right? If we talk about the final here, that was a ux is equal to the, what is the initial, that is the vx plus a0, right? So the t, when a will 0 will multiply with the t, it will whole term will get 0, so ux is equal to the vx. These both are the equal, and we can also write that the v cos theta, or we can write that the u cos theta, right? So the ux is equal to the vx. The initial velocity is equal to the final velocity, as I discussed before, that it will move with the, in x direction this ball will move in the uniform velocity because acceleration is 0, and here you can see it is moving with the uniform velocity because these both are the same. Now if we talk about the distance here, what distance here, if this is a ball here, so what distance it will cover, to come here in x direction. So we will discuss this here. If we talk about in the equation of motion, that was a s is equals to vit plus half at square. This was the formula for finding distance. We will use the same here. What is the s? It's a distance that we will show as a sx, distance of the x direction. What is the initial velocity? That is the vx, and here time plus 1 upon t. Acceleration is 0, so this whole term will get 0. This whole term will get 0. This will also get 0, right? So the sx is equal to the vxt. We can also write like sx is equal to the v cos theta and t. We can also write here. So by this we can find the distance of the x direction, right? If we talk about in the y direction, if we talk about the final velocity, first of all, what was the initial velocity? First of all, acceleration ay is equal to the minus j, as we have discussed before. And what was initial? vy is equal to the v sine theta. This is the initial. If we talk about the final here, so what we are using formula, that is the vf is equal to vi plus at. What will be the initial final? That will be the uy is equal to the v y plus, what is the acceleration here? That is a minus g. So here we will use minus g and t. So it will be like uy is equals to the vy minus g and t. So this will be the final velocity for finding the final velocity in the y direction. Now if we talk about the distance in y direction, that will be the s is equals to the vit plus half at square. We will use the same. So the sy, as before we have done sx, here sy is equals to the vy and t plus half, what is acceleration? That is a minus g and t square. So the sy is equal to the vy. Instead of vy we can write the v sine theta plus minus 1 upon 2, because this minus, when it will multiply this, it will make minus, so the gt square. So this will be the for finding the distance in the y direction. So that was all about the introduction of the projectile motion. In next video we will discuss about the ground to ground projection.